make this transition into a regular graph. It is 7 in the morning right now, and the place looks quiet with few people, but in a few hours, this place will be filled with a lot of people.
At first, only a few people enter the station. This is when the graph is starting to increase. Then, more people start entering. So the graph becomes steeper. Eventually, the station is now at its greatest number of people, which is the maximum point on the graph. After that, people begin leaving the station. This is when the graph is starting to decrease. Now it's 10 a.m. and everyone has left the station. This is the graph of f of x, so the original function. Since the x-intercepts and the people are at 0 at 6 a.m. and 10 a.m., when the graph is above these points, it means that there are people in the station. So when the graph is positive, there are people in the station. When the graph is at 0, it means the station is empty. When we see the graph increase from 6 a.m. to 8 a.m., it means that the derivative of the function is positive. So the amount of people in the station is increasing. We see that the graph is decreasing from 8 a.m. to 10 a.m., which means that the amount of people is decreasing. The second derivative has to do with concavity. And so we see here that the function is concave up from here, and it is increasing, which means that it's increasing at a faster rate. Here, the function is concave down, and here, the function is increasing. So if it's concave down and it's increasing, it means that the number of people is increasing, but at a slower rate than it was before. Here, it's concave down, but it's decreasing, which means that it's decreasing at a slower rate in general. And here, it's decreasing, but it's concave up, which means that it's decreasing at a faster rate than it was before.
In the end, calculus isn't just in the textbook, it is happening around us everywhere we go. Don't miss your train!